I'm going to do another amp repair. This is easily the oldest QSC amplifier I've ever worked on. It's a model A21, made in 1979 or 1980. I know the schematic was last revised in 1980, so it may be a little bit older than that. But this one, it was another one of those amps that looked cool to me, and I like working on things that are this vintage. Of course, it's built like a tank, and I like the back panel. It's got a couple different options: banana post, binding post, quarter-inch outputs, XLR and quarter-inch inputs, both balanced and unbalanced. And it has one of those open frame type cooling fans in the back. It's rated at 120 watts per channel into 4 ohms, and I think 95 watts per channel into 8 ohms. It's missing the rubber feet on the bottom. I'm going to have to put some on there. But I bought this on eBay in non-working condition, just for something to fix up. And hoping I can get it going and pair it up with either the Dr. Fong amp in a bi-amp setup, or use it in my workbench setup over here. Hard to say. I'll figure it out once I get it working. But it just looked cool to me, so not sure what the problem is. I guess we'll find out. Let me pop the top. Well, it looks fairly intact. It's very dusty in here. Nothing looks visibly burnt though. It's got a nice symmetrical layout in it. Cooling fan still spins. The date codes are 1980, 1981. It kind of varies, but everything looks like it's original. It uses the NE5530 op amp in the input stage, which is no longer in production, so that's going to have to be changed out to something else. In fact, there was a service bulletin that outlined how to do that, so I'll definitely be performing those modifications. And whether I go with the op amp that they recommend or something else, I'm not quite sure yet. I don't even really know what's wrong with this. I gotta power it up and see what the deal is, because they said it didn't work, but they didn't say what didn't work. So let me get my variac and my multimeter and see what's going on with this thing. Actually, I think I should get the air compressor and get the dust out of here first. That'd make things a little easier. I powered it up using the variac and got power lights on both channels, and cooling fan started running, but I noticed this distortion indicator light was coming on the left channel, and eventually it popped the breaker on the back of the amp, so something's definitely going on with the left channel. I'm gonna get my multimeter and check for shorts real quick. Looking underneath here, I see a couple things going on. First thing that kind of bummed me out was somebody had removed the metal clamp that holds the filter caps in place against the back of the frame, and so they were just unsupported except for the leads. And this one actually pushed through and pulled both traces right off the board, even though they're still connected. It's just delaminated now, so that's got to be taken care of. And also, both op amps have been changed at some point, because I knew those sockets weren't factory, and that's definitely not factory solder. They were the original factory part number, so I don't know if somebody got identical replacements or if they had taken the original ones out while troubleshooting and just put them back in the sockets. I did find one shorted output transistor in the left channel, this one right here, so I'm going to unsolder that, get rid of that short, and get this to the point that I can power it up at a low voltage and look for abnormal amounts of DC coming out of the op amp. I'm wondering if it's a similar type of failure to what killed that BGW amp that I worked on a while back, right over there. Maybe the op amp shorted and took out the output channel, but seeing that it's only one transistor, it could have also been an overload or something else that took that out. So I guess I'll find out as soon as I get rid of that short and get this thing powered up, start testing things. Well, I took that shorted transistor out of there, and the amp no longer trips the breaker. So also tested for a lot of DC at the speaker terminals, and there was none, so that's a good sign. I think the rest of the transistors are probably okay. So I figured let's hook it up to some speakers and give it a try. I'm going to leave the safety current limiter in place for the time being, which is only a 15-watt light bulb. So the amp is only going to be receiving about 75 volts, but it should be enough for me to judge whether anything else is wrong based on the sound quality. And we'll go from there. Okay, everything's hooked up. I should have a signal coming off the computer now. So let's see what happens. Bulb started off pretty darn bright. There's the caps charged and got dim. It's not very bright now, so yeah, I think I need a little more voltage. I'm going to have to take this light bulb out of here. It's limiting too much voltage. Alright, straight in this time. There we go. Much better. It sounds great so far. I'm surprised. All original caps and everything. Sweet. One of those ones that's got a lot of capacitor reserve in it. That's pretty cool. Oh, not bad at all. Not bad at all. Just got to replace a couple output transistors, and this thing will be fully functional. Then I can get on to improving things. Check all the caps and maybe upgrade the op amps to something better and more reliable. But from what I've heard so far, this thing's going to be sweet. Got the new parts, and it's Friday night, so let's dig into this thing some more. I'm going to be installing a new set of MJ15016 in place of the SJ9092 on that channel, so that all of the same polarity transistors are matching. And I've also got some other parts that I may or may not use. It depends on how far I want to take this rebuild, because I'm just going to get this working and use it to run the computer speakers over there. So let me take care of these transistors first and we'll go from there. I wanted to point out something on this circuit board real quick. While I was going to solder in this last solder joint on this transistor, the tin plating outright fell off the copper, and I thought the trace had just been broken from abuse or whatever, but it turns out the copper was fine underneath, and I just had to scrape it off and get some fresh copper to solder to. And a lot of boards like this that had tin plated copper traces, if the plating wasn't perfect for whatever reason, whether it was done poorly in the first place or there was corrosion or humidity or heat damage, that tin plating can just come right off the copper and leave a poor connection even though the solder itself is perfect. And I have seen that many times on older boards. You would never know that there's a problem, especially when something is mounted to a heatsink with screws so that it can't move. You'll have a hard time finding that bad connection by visual inspection, and a lot of times you won't know anything's wrong until you unsolder it or go to resolder something new onto it and the tin plating just falls off. I've had stuff before where it would arc between the layers of metal, or it would just you know, have an intermittent connection that would drive you out of your mind, and you can't find it by looking or poking around. And as the thing heats up, it would improve, and if it's cold, it would break. You know, it's just one of those things that'll just drive you crazy. So you definitely want to watch out for that on boards that have plated copper. I think a lot of newer stuff, they don't use the tin plating anymore. They just solder directly to the copper, and I can understand why. It's probably cheaper to do it that way, and also a little more stable. I think the main reason they tin plated in the first place was to prevent the copper from oxidizing, but it seems like it was kind of a moot point to do that at all. Well, it's up and running. However, I still have uneven gain between the two channels. Channel 1's quite a bit quieter than channel 2. However, there's no distortion or anything, so I'm going to have to get out my scope and trace the signal and figure out where it's getting weak at. It could be the potentiometer, it could be the op amp. Hard to say without looking, so let me get my scope ready over here. This is kind of an odd problem. Channel 2, as good as it sounds, I have an oscillation going on, and I'm at 180 kilohertz. And ironically, channel 1 is working correctly. That was the channel that was blown up. So, gotta dig a little further here. This can't be going on. Ah, there we go. Much better. No more oscillation. I'm getting a clean 27.7 volts per channel. And let's see what we got here. 27.7 divided by 8 times 27.7. 95 watts per channel. Exactly what it's rated for. So, definitely much better. All that was wrong was that I had forgotten this filter cap had two of its legs completely broken off the board, and it had broken that copper trace between the two, which is also used to connect parts of the circuit together. These four outer legs all go to the outer casing of the cap, and then the positive is that one in the middle there. And part of the circuit is connected to just these two legs here. And since they were broken off, there was no connection to the negative side of the cap, and it was making the amp do some really weird stuff. So that's all taken care of. I've just got to clean the bottom of the board up a little bit more and install another clamp for the capacitors. I actually took the clamp from the good side and moved it over here, and got them clamped in place and resoldered, so those are secure. And I've got to make up another clamp. So I've got this here. I had a coworker of mine bend this up out of some steel at work. I've got to drill and tap a couple holes in that and put some foam rubber tape on there. Get those other two caps secured, and I can put the bottom panel back on. Sounds good now. Better than ever. Another one just about finished. Really good sounding amp too. Too bad the fan's so darn loud.